what we're going to do is we are going to use sheets of toilet paper to help us to make a scale model of the distances in between the planets. And this is just going to be the distances in between the planets. I am going to give you guys planet markers to hold up, but the sizes of the planets are going to not be to scale. So the planets are going to look bigger than they actually would. All right? Understand?
I thought they would look smaller than actually would.
No. Here's Mercury.
Yeah, but
When we're down the hall from Mercury, it should be like the size of a pin. If we were like trying to really say this is how far apart they are and this is the size they are, this is way too big to be Mercury. All right. What I'm saying is we're demonstrating the size between each planet in the solar system, not the size of the planet itself, because this model of Mercury is much too large to be the actual size of Mercury if we were going to show
much too small.
Or much too large, sorry. It would be much smaller in our model. All right, now listen. The first thing that you're going to do, this is going to be one sheet of toilet paper, and in our model, it represents about 18 million miles, okay? So I'm going to give you the answer to number one. The actual number of pieces of toilet paper that we are going to use for Mercury, the distance between the sun and Mercury, we're going to use 2 sheets of toilet paper. So I want you to make predictions, but because I'm trying to explain to you, I'm actually giving you Mercury, all right? So let's predict that Mercury needs 2 sheets of toilet paper. So in other words, the distance that it is from the sun, I'm going to take this first sheet off, or first 2 sheets, because that one sheet's a little bit messed up since it's glued there. But so basically the distance from the sun to Mercury is about that much. Okay? So now I want you to make a prediction. How far do you think then it is, how many sheets of toilet paper do you think it's going to be between Mercury and Venus? And then how many do you think between Venus and Earth? Okay, and how many between Earth and Mars?
7.
And how many between Mars and Jupiter? So write it down on your, like in your iPad, go into your assignment and go into the data table and then write it down, okay? So if you think that between Mercury and Venus, there's going to be how many pieces of tissue paper? Oh, thanks. Just sit down. How many? 4, okay. How about between Venus and Earth?
6.
How about between Earth and Mars?
11. 9.
8.
Well, you're just making a prediction.
7.
All right? How about between Mars and Jupiter?
7.
12.
7.
12.
7. Don't do so. Yeah.
All right, how about between Jupiter and Saturn?
4. 4.
Yeah. Didn't they just find another one another planet instead of look like Earth?
5.
We'll talk about that later. You think 5? All right.
I said.
How about between Saturn and Uranus?
10.
10? And how about between Uranus and Neptune?
1.
What?
I don't know.
Oh my
Thinks
God.
they're close. Okay, so we've made predictions, and what we're going to do is we're going to go out to the hallway, and I'm going to tell you the actual number in between each one, and you can actually bring your iPad with you, and you can write it down, all right?
Can I hold a planet, please?
I'm going to assign planets to you, and then when we get out in the hallway, you're all going to follow me unless you are a planet. Then you're going to stand next to the roll of toilet paper where I tell you to stand, okay? So Mercury, come on up. You're going to stand right here, okay? All right. So 2 sheets is Mercury. So Mercury is 2 sheets of toilet paper away from the sun. Remember that this is a scale model. This is to show distances in between. That does not necessarily mean that this would be the right size for the planet at this model, or in this model, okay? So we're not looking at the sizes of the planets for our model, we're looking at the spaces in between, all right? So the next planet is Venus. Can I have Venus come forward, please? Venus, come on. All right, Venus, you're gonna be 4 sheets of toilet paper. So as we roll out, we're gonna go 1, 2, 3, 4. So you're gonna stand with your foot right there, okay? Hold it up nice and high. So we've got Mercury and Venus, all right? The next planet's gonna be Earth. Come on forward, Earth. Earth, you're 5 sheets of toilet paper away from Venus. So as we roll this out, we've got 1, 2, 3, 4, 5. You're gonna stand on this side though, so we can go like every other. All right, put your foot right there.
Yeah.
All right, Mars, you're next. Come forward. All right, Mars, you're gonna be, hold it up, hold it up. You're gonna be 8 sheets of toilet paper away from the Earth. So you're gonna stand on this side. 1, 2, 3, 4, 5, 6, 7, 8. Put your foot right here. And then hold your sign up nice and high. All right, now, these 4 planets are the inner planets, all right? They are all very similar. They're all sort of small compared to the other planets. They're all heavy rock, like dense. They have iron cores. They're dense. They're made of rocky material. We're going to start to see the distances increasing in between each planet. Jupiter, for example, is going to be 26 sheets of toilet paper away. So, watch out. Here we go. Whee! And then all of a sudden there's this big space in between Mars and Jupiter. Is there anybody here that knows offhand what's in between Mars and Jupiter that might take
The asteroid belt.
The asteroid belt, right. So that may explain why there's a big gap there. But then from there, we get some more big gaps and there's not really any reason to explain it except that's just the way it is. We're going to start to see bigger and bigger spaces in between these outer planets. So, Saturn, you. 48. Count 48 squares. 48 squares of toilet paper. Put your foot on 48.
I'm right.
There you go. All right. So, you got 96. Start counting next to his foot there. 96. Neptune, you got 150. Start counting. 150. Go. The inner planets are very close together. Now, we don't even have enough toilet paper to tell us where Pluto might be. Because Pluto has a very elliptical orbit, and depending on where it is in its orbit, it could be way further than this, but it can get as far away as the office. So those windows where the office is, Pluto could be that far away. So the actual sheets of toilet paper, I did give you Mercury, and then you're going to compare it to what your predictions were. Now, your predictions may have been different. This is just what members of the class were saying. Your graph itself, or your table itself, may be different, and that's okay. But between Mercury and Venus, there were 4, so whoever said 4 was right with that one. Between Venus and Earth, there was 5, and so that was pretty close. Between Earth and Mars, there was 8, and again, that one's pretty close. And then if it had continued in the same type of pattern, you guys might not have been too far off with some of these numbers, but this is where we started getting further and further and further apart. There was 26 sheets between Mars and Jupiter, 48 sheets between Saturn and Jupiter. There was 96 sheets in between Uranus and Saturn, and 150 sheets
Compared to
between Neptune and Uranus. So, yeah, well, we didn't know. We didn't know. But the point here is, when we look at these planets, there are distinctly 2 different patterns here. First, you've got your inner planets, also can be called your terrestrial planets. Terrestrial means like Earth. And remember, extraterrestrial, like ET, means not like Earth, meaning it's not from the Earth, right? So the terrestrial planets, or the inner planets, all have certain things in common. First of all, they're all really closely spaced together and squashed up there near the sun. So they're closely spaced together. And that was what we showed today. They're also all rocky planets. They're very similar to the Earth in the fact that they are made with rocky materials. You can stand on them. They all have hard land surfaces. They are all dense. They have iron cores. And they are all small compared to the other planets. So they're small, dense, rocky, and they are closely spaced together. Now, again, I told you that the examples that I was using on the rulers, that they were much larger than what they should have been. If we were showing that Mercury is 2 pieces of toilet paper away from the sun, Mercury should have probably been like the size of a pinhead, okay? Should have been pretty small, in other words, all right? Earth may be the size of a marble, okay? So they were not to scale. We were looking at the distances between them, not the sizes of the planets, okay? Now, these planets then had a different pattern. They were spaced out a lot more. So these are our outer planets, also known as the gas giants, okay? Gas giants are spaced far apart. So as you get further from the sun, they begin to space farther apart from each other, all right? Spaced far apart. They are not small, they are large, hence the name giants, right? So they're very large. They're much less dense. We don't believe they have an iron core, so they're not very dense compared to the inner planets. They are also, as far as we know, they don't have any solid land surface. Like if you go to Jupiter, we don't know if in that planet anywhere, if there's anywhere where you could stand on the surface. There might be, but as far as we've been able to tell, so many miles in from the planet, as far as we know, it's still just gas. It may get thicker, like the gas may get thicker and it might get a little bit liquidy as you go in. It may have a solid core, it may have solid areas, but we don't know that. As far as we know, they could be gas the whole way through. It's still a mystery, okay? But they are not made of rock, they're made of gases like hydrogen and helium or methane, okay? So they are different from the terrestrial planets. They're spaced far apart, they're large, they're less dense, and they are gaseous. So they are very different. The inner planets and the outer planets are not only spaced differently, but their compositions are different. Their densities are different. They are really like 2 separate types of planets. And we'll talk about why that is in the future when we talk about the solar system. But it has a lot to do with what was going on when the solar system formed.